Okay, so machine learning. You've heard that term thrown around a million times, right? But what does it actually mean? It sounds super complicated, but what if I told you the core idea is so simple we can break it all down in just the next few minutes?
And here's the thing. Whether you know it or not, you're already using it. Every single day. You know when you finish a show and that perfect next recommendation pops up? That's the engine behind it.
And it's also the silent guardian of your email, catching all that junk mail before you even see it. It's just always there, working in the background.
Which of course brings us to the million-dollar question. How? How does a machine learn anything? I mean, it's not magic, right? Even though sometimes it really feels like it. It's actually a pretty logical process, and we're going to walk through it step by step. And to get it, you don't need a computer science degree. Nope. All you really need to do is think back to when you were a little kid, just figuring out how the world worked.
Because, and this might sound a little wild, the way a super powerful computer learns something new is, well, it's almost exactly the same way our brains did back then.
All right, so let's try a little thought experiment. Picture it. You're a toddler, and you're about to see a type of animal you've never, ever seen before.
You see this? This furry thing with whiskers and pointy ears? Your brain is just a blank slate at this point. It has no idea what to call it. It needs a label, some data to work with.
And then your mom or dad points and goes, "Oh, that's a cat." Boom! Just like that, you have your very first piece of data. A simple label. And your little brain instantly gets to work. It starts connecting the dots. Cat equals fur, whiskers, pointy ears. So the next time one wanders by, you point and think, "Hey, another cat." Your mental model is already getting stronger.
And that right there, that's it. That's the heart of machine learning. The computer is basically that little kid. It starts off knowing almost nothing, and we teach it by feeding it tons and tons of examples.
Okay, so let's shift gears from the playground to the computer chip. The idea is the same, but for a computer, it's a much more structured process. It's really a 4-step cycle.
Think of this as the basic recipe. Step 1, gather up a ton of data. Step 2, find the patterns inside that data. 3, make a guess based on those patterns. And 4, the most important one, learn and get better. Let's dig into each one.
All right, step 1, data. And I mean a lot of data. We're not just going to show the computer one photo of a cat. We're going to show it thousands, hundreds of thousands of cat pictures. And just as important, we'll show it a ton of pictures of things that are definitely not cats. Now, this is the really critical part. Every single one of those pictures has a label. This is a cat, this is not a cat. You can think of these labels as the computer's answer key. It's the ground truth for everything it's about to figure out. Okay, so once it has all this labeled data, the computer basically becomes a detective. It sifts through all those thousands of cat photos and starts looking for clues, for common patterns. It might figure out, hey, a lot of these cat pictures have whiskers, and these pointy ear shapes keep showing up. And now for the big test. We give the computer a brand new photo it has never ever seen, and we ask it, all right, what is this? It has to take all those patterns it found and make its best educated guess.
So what if it messes up? Let's say it sees a picture of a fox and says, that's a cat. Well, that's where the learning really happens. A human steps in and says, nope, sorry, that's not a cat. That little piece of feedback, it's everything.
Because that's really the magic of it all, isn't it? Just like us, the machine learns by getting things wrong. Every single correction helps it tweak its internal model, adjust its patterns, and just get a little bit smarter for the next time.
Okay, I know what you're thinking. Identifying cats is kind of fun, but so what? Why is this technology such a game changer? Well, it all comes down to two things computers do way, way better than us: scale and speed.
Just imagine for a second I gave you a folder with 10,000 photos and told you to find every single picture of a cat. I mean, that would take you, what, hours? Days? It would be a huge pain.
A computer that's been trained to do this, it could probably do it in a few seconds, maybe less. And that incredible difference in speed and scale, that's why this is so revolutionary. And look, this stuff isn't some far-off future tech. It's here right now. The reason Netflix knows exactly what movie you want to watch next, that's machine learning. The reason your email knows what's junk and what's important, machine learning. The reason you can just talk to your phone and it understands you, yep, you guessed it.
So we've gone from a kid learning about cats all the way to the super smart tech that we use every day, which kind of leaves us with one last big question to think about.
I mean, really think about it. If a computer can learn what a cat is using this process, what else can it learn? The same exact steps can be used to teach a computer to spot diseases in medical scans way earlier than a human doctor can, or to compose music that sounds like it was written by Bach. So if it can get so good at a simple task like finding a cat, what's the limit? Where does it stop? The really exciting part isn't just what it's doing for us today, but all the incredible problems it might help us solve tomorrow.